Guys, we are back with example number 9 on proving identities. So guys, as you can see here, this deals with an half angle, and then we have a ratio on the left hand side. Again, you would agree with me that it would make sense for us to actually start with the left hand side and then work our way through this, all the steps, whether it's like algebraic steps or then using some identities and finally trying to convert that left hand side into the right hand side. Okay, so let us start the process, keeping in mind that we want to get everything in terms of the cosine, right? Because the right hand side has only a cosine. So let us start. Guys, the left hand side, what we can do here is for tangent, we know tangent can be written as the ratio of sine over cosine. Although we know that we want everything to be in the terms of cosine, but we may not be able to write everything in terms of cosine right away. So if one has to start with sines and cosines, that is fine. We start with that and then we see where it leads us to, and then what else we can do in order to convert even that sine into a cosine. But as a starting step, guys, we still have to write tangent as the ratio of sine over cosine. So this is sine x over cosine x, and then I'm not going to do anything with that. Sine x, I'm going to leave it like this, and I mean we don't have any identity or any simplification for sine x, so we got to leave it like that. And this whole thing has to be divided by 2 tan x. Again, the same thing, 2 sine x over cosine x, right? We just use the basic trig identity for tangent, which is the ratio of sine over cosine. Now let's go from here, guys. Again, looking at the numerator piece, we want to combine these two, because if you look at the right hand side, we only have one term. So here on the left hand side, we want to basically just combine everything. So guys, if we want to combine these two, then we've got to have a common denominator here, which is cosine x, and then we can only combine the numerators. So there's an invisible one here, so I'm going to multiply this by cosine x upstairs and multiply this by cosine x upstairs as well. So see what I'm going to be left with. I'm going to be left with sine x here, and here sine x cosine x. So this is what we have sine x plus sine x cosine x divided by just the cosine x. That is the ratio in the numerator, right? And the denominator, we're just going to rewrite the thing, the ratio 2 sine x over cosine x, okay? Because there's nothing much we can do here. Now from here, we want to just get rid of, we want to convert this division to a multiplication. And while we do that, then it changes to a multiplication, then these two are going to be these are going to flip. So let's see what happens when we do that. While we do that, guys, the other thing that we should do here is that both terms have a sine x, right? So we can already take out sine x as the greatest common factor. And if you have been watching my videos, or you have been doing these factoring problems and factoring examples, you already know that if there's a greatest common factor, we should try to take it out, right? So sine x is the greatest common factor. I'm already going to take that out, sine x, and let's see what is left. So from here, I will be left with only 1 plus, and then from here, I will be left with cosine x. I'm just taking out the greatest common factor. Then I have a cosine x downstairs, then times. When I do this, when I change this to times, so I will have this cosine x goes up, and then I have 2 sine x downstairs. Okay, we already know how that works, how when you change that division to a multiplication. Let's see if we can cross out some terms, and most of the times we are able to cross out stuff. So guys, cosine goes with 1, sine x goes, so we are left with only 1 plus cosine x over 2. So at least we are able to start from here and then finally get rid of the sines, and we only have the cosine. But this still does not look like this, right? It still does. So there's some more work that needs to be done. So for getting this transformed into this, what we have to do is we have to go back to our formula sheet, or we have to recall the sign of the double angle, if you like to think. So guys, let me remind you what is not the sine. What I meant to say was the cosine of a double angle. So guys, remember, cosine of 2 theta is, there's 3 ways of writing the formula for the cosine of 2 theta, right? One involves cosine and sine, other one involves sine, and the third one involves only cosine. Here, guys, we want cosine. So we are not going to use the sine formula or both formulas. We're only going to use the one which involves with which has the cosine. Okay, so the cosine one is 1 minus so we have 2 cosine square theta minus 1. Okay, that is the cosine one. You can always check it on your formula sheets as well. But here I don't have a cosine of 2 theta, I only have a theta. Well, that is fine. We can transform this. If there's only theta here, we already know how it works. If there's a 2 theta, we're dividing that by 2, so we get just theta. Again, if we start with just theta, then it's going to look like 2 cosine square theta over 2 minus 1. That is the identity that I'm going to use here for cosine x. Okay, and where did I get this from? I got it from the double angle identities. Okay, guys, if you may have to use a formula sheet, look at a formula sheet, that is totally fine. Go ahead and do that. So it's going to be 1 plus this is 2 cosine square x over 2, and then there's a minus 1, and this whole thing has to be divided by 2. One step at a time, guys. This plus 1 and minus 1 will cross out. I will be left with 2 cosine square x over 2 divided by 2. These 2's will cross out as well, and I get a cosine square x over 2. That is exactly how my right hand side looks like. So we can say that the left hand side, this implies that left hand side equals to the right hand side. And guys, we are done. Okay, so guys, this is a little more challenging than the previous ones, but I just wanted to show you like different types, and there's one more that I'm going to show you, and then we are going to move into a different section. Maybe we'll talk about how to solve trig equations, or talk about the inverse trig equations, or trig functions. Okay, so guys, keep practicing this, and I will see you next time with the last problem, number 10. Okay.